Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 4 on this series. And the topic is the ocean circulation, and the book which I referred is the Marine Geology, Exploring the New Frontiers of the Ocean by John Epson, and the Atmosphere, Ocean and Climate Dynamics, an introductory text by John Marshall. Welcome to my channel Success Guru and myself Panchanadam, and let us get into the heading. As you know, the earth is curved and the sun's ray hit the earth at different angle at different places. And according to the angle of incidence of the sun's ray, the local temperature of that region is dependent. And that is why you can see the ice caps are on the higher latitude and higher altitudes, and the deserts are in mid region. Can we expect the same thing, that is the same difference in temperature in the ocean water? Actually, the answer is no. And the reason is that due to the oceanic circulation. Actually, the ocean is in constant motion, distributing the water and heat to all corners of the globe. In effect, the ocean acts as a circulating machine that makes the Earth's climate equitable. Ocean currents follow the well-defined courses, and you can also see that the ocean transport tremendous quantity of seawater, serving as a global conveyor belt over the planet, and the abyssal storm stirs the deep oceanic floor, shifting sediments on the seabeds also. And the El Nino current generates unusual weather pattern throughout the world. The waves and tides are constantly changing and rearranging the shorelines. From that, you can understand that how the ocean is active and how it is circulating. So there will be other question in your mind. Actually, what drives this circulation of this ocean? And the answer is actually there are two processes that drives the circulation of the ocean. The first one is the tangential stress at the oceanic surface, that is due to the prevailing wind system, which imparts momentum to that ocean. And such a movement due to the wind action is called as the wind driven circulation. And the next one is the convection current. Actually, the convection is the transfer of heat due to the bulk movement of the molecule itself within the fluid. So, such a movement of water that due to the difference in temperature and the salinity is called as the thermohaline current. Let us take an example, that is there is a loss of buoyancy in the polar latitude, that is due to the cooling or addition of salt that is inputted on those areas, that causes the surface water to sink to depth, and this ventilates the abyss. And such a movement of water that is due to the difference in temperature as well as the salinity is termed as the thermohaline current. The current in this upper region of the ocean are driven by the wind, that you know, but which imparts the momentum of the oceanic surface. The current do not follow the wind direction, and instead they are deflected by the Coriolis effect. And the Coriolis effect is the apparent force that deflects the wind or the moving object, that causes it to curve in relation to the rotation of the earth. And as the earth rotates, anything moves in a straight line will be deflected. Say for example, if you are moving towards the pole, then the deflection you are deflecting towards the east, and if you are moving away from the pole, that is towards the equator, then the deflection will be in the west. That is what they are shown in this figure, and that is due to the reason is that the earth's rotation will be very high in this equator, as it is in the center, and the polar region will be rotating comparatively slow than this, as the area is very small. And if a current is say moving from pole to equator, what happens, the it has to speed up, right, and that results in shifting of anything towards the west. In the same way, if any object that moves from equator to the pole, the earth is rotating faster in this region, so the sudden slowing of the surface leads to this thing shifts towards the east, and that is why it is happening. Here is an example that something is flying from the equator to the pole, the shifting is towards the east. The same way, if there is shifting movement is from equator to the northern pole, also the shifting is all in the eastern direction. So these are the two different examples for this thing. And the next question is that what does this current actually do, right? The answer is that the current acquires warm water from the tropical region and distribute it to the higher latitude. Then they return to the tropic with the cold water. And this exchange moderates the temperature of the coastal region, making the countries such as Japan and Northern Europe warmer than those they otherwise would be for that latitude. So this is actually equalizing or reducing the actually increasing the temperature of the Japan and the northern European countries. Some of them are like there are Gulf streams that can move up to 13,000 miles clockwise around the North Atlantic basin, transporting warm tropical water to the northern region. You can see that this is the Gulf stream here, and there are other thing like Japan current, which is actually here, which is the counterpart of the Gulf Stream. This is strong flow of water. This current bears warmer water from the tropic, sweeps northward against Japan, crosses the upper Pacific, and turns southward to warm the western coast of North America. Up to this, it is extending, and this is called the Japan current. The major current in the South Pacific is the Hamu or the Peru current, which actually flows northward along the west coast of South America. Here it is. So these are some of the examples of the currents. There are actually list of currents here. There are 8 cold currents and 22 warm currents are there in the globe that is existing. If you want a detailed review, you can just mention in the comment section. I will do it for you. And the other movement causes are the gyres. Actually, gyres also called as the eddies or the swells, warm and cold water accompanying the ocean current. Some eddies are enormous measures such as say up to 100 miles, and the depth it may reach up to 3 miles, and few other eddies may range in size say up to 50 miles also, and there are also small eddies which have a range of 10 miles width. And this small eddy plays an important role in mixing of the ocean. And the eddies appears to pinched off section of the main oceanic current, but it is actually driven by the oceanic current itself. As with a high pressure system in the atmosphere, the eddies rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. I hope I explained few of the important things about this oceanic circulation. And if you are not clear or if you want any detailed thing about this thing, just mention in the comment section. We will do in a later videos. And as mentioned here, our WhatsApp group is already open. If you want to join this group, you can use the link that is in the description, and the link will be available for an hour or something. And I group my videos according to the category that you can check in the playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can also support us by like, share and subscribe. Thanks for watching. Have a great day.